Merlin, network magic, now in high definition. Hey, all right, so I went out and got a real webcam, hopefully to make your experience in viewing these a little bit better. And when I get the whiteboard out and stuff, speaking of the whiteboard, and to really get to the important thing, I just deleted a whole bunch of videos. I'd rather reshoot them in high def for the quality, but we're moving into Docker containers now. I've had a personal roadmap for Merlin in mind right from the get-go. And what you've seen is this incremental, iterative approach. And now that I've reached a point where I feel I'm ready to make it even easier for people to use, and there's technologies available to do that. So let me see here if I can get the red marker out. And I've already written some stuff out. So look at the top of the board. We're focusing at the top of the board for now. All right, so here's the basic premise of Merlin, is that, right, either from, and here's the catch, it has to be this Linux host. Right, so it has to be Linux. But I can run PyETS or Ansible to go to a device, bring back JavaScript object notation, either through PyETS functions like .learn or .parse, or Ansible things like iOS facts and SOX facts, info modules, resource modules. Well, I then send them down into Merlin, my Jinja2 templating, and my Python here to create business-ready documentation. Now, we can achieve this through WSL, and that's what you've seen me do at home, is install WSL2. Make sure you integrate with your BIOS if you have to. Make sure you follow the steps online on how to bring your WSL by just clicking the box to actually WSL2, where it integrates with virtual machines and your hypervisor technology and your CPU. It's incredible stuff. You need the WSL2 experience, which then you connect to your Ubuntu image, your VS Code, your whole ecosystem, to Docker Desktop, which we're going to look at, all becomes fused with this WSL2 ecosystem. Now, what are the drawbacks? And let's take a look. Well, first, we need Linux, WSL or not. Likely need a virtual environment for PyETS, absolutely. We need Python. We need pip to manage packages. We need to then pip install PyETS, pip install rich, pip install tinydb, plus a couple of other things. That's just for the business-ready documents. If we want the experimental file types, we need to pip install or apt-get even more. Git clone the repo in, run the Merlin job, and then we have the business-ready documents. Well, as you can see here, can we take that whole thing and make something like a CD-ROM out of it, where a user just drops it in the tray goes in. For everybody who doesn't know what a CD-ROM is, it was an optical disc that you put in a tray or a slot in your computer that had data on it and instructions on it, and like you booted from that disk to install an operating system like Windows 95 or to install the latest game you bought. Can I turn this Merlin experience into something like a CD-ROM where they run the CD-ROM and then they have the business-ready documents? That's it. Well, this is my little, I'm not an artist by any means. Well, maybe some paintings in the background disagree, but can we, right? Yes, we can with Docker. Right? Docker is the modern analogy to the CD-ROM, if you ask me. It's even called an image, right? ISO, an image, a standard, an immutable object. So that's the goal. And it turns out, in my opinion, it's actually relatively easy to do. It's extremely well documented. So let's take a look at how I've turned Merlin into Docker and containerized my solution into like an app or a CD-ROM image. So let's look at the code first. And what you're looking at here is what's known as a Docker file. And that's the key basically to all of this. And it's its own syntax, its own set of commands that are valid and have their own syntax and have their own limits. And what I've done right, if we take out the 1, 2, 3, 4, 5, 6 lines of space, 20 lines of code with a couple of echoes, 4 echoes, 16 lines of code. I've transformed Merlin into a Docker container image with Python, with an SSH client, with PyATS and with Rich, with my own instruction set, my Python, my PyATS job, my Jinja2 templates, the testbed file, and everything you need, all packaged up here in 16 commands. So Docker files start with from, and then in my case, I want to base this image. This is going to be an Ubuntu image from the latest version of Ubuntu. Now, I found that run can only be executed one time in the instruction set, and we can chain together our sets through syntax and chain all of this together as one long command as far as Dockerfile is concerned, but it's actually our instruction set line by line. Now here I'm simply copying in, right, my folder structure for the output files, my Jinja2 templates, my Pythonic code, and my testbed file. And then I'm setting what's known as an entry point. Now the entry point says run this command when it spins up. This is like autoexec or autorun.bat on the old CD-ROM. When it dropped in, if it was detected that it was put in a CD-ROM tray and auto run was turned on, it would run that auto, right? So that's sort of the thing here. Spin it up. Now I've made the command, which is something you can override. If you want to put your own testbed file in, you can, and it will run the PyATS IP interface brief job against your testbed. Now this is not interactive that I can log into it with a shell, but if I were to comment out these two lines of code, I would effectively have everything I described as an interactive container that I could shell into and run this command myself, which is how I built this image. I wanted to thank Roddy Hassan in the community who gave me some advice, not technical stuff, but the approach. If you're going to build it this way like you see on the screen, I highly recommend that you do something like this, where you comment out and get it to where Python 3 is installed, right? Even go up further. Get it where you have Ubuntu and Ubuntu's updated. And then line by line, we just, okay, now that I have Python installed, can I install pip? Can I install the SSH client? How far does it get? Now, the other way to do it would be Roddy's recommendation of spinning up an interactive container, running these commands serially and fine-tuning it in one image until you get the commands right, as opposed to my old COBOL approach of compile and fail. Compile and fail. I got it right, it compiled. All right, now I'll add the next command. An iterative, maybe a little bit long-winded approach. So now I have my instruction set. Now you'll notice that I have these in folders here. Now if I were to take this Docker file and put it in root and do the Docker run or Docker build command, I would build this image. But as you can see, I want to make multiple images, right, per different learned function or show command as tags in my repository or images in my container, so that all of these come up as different individual CD-ROMs, as if I had multiple CD-ROMs, like a CD tree full of CD-ROMs, and I can pick the one I want to run at will. So what I'm using to achieve that is a Docker compose file. Now I can use Docker build, or I can use a Docker compose. And compose has a bunch of options, one of which is Docker compose up. It will read through and bring up all of the services I've defined in this YAML file. It's a YAML file, kind of like an Ansible playbook, where I define the learned ACL, the learned ARP, the learned routing, and the IP interface brief services, the image, what I want to call the image, which is my repository, my container, and then my tag. I point it to the Docker file in those folders we just looked at, and I set a context, meaning where root is, where the relative path is, to find those files. In this file, I could also set what's known as a volume, and I'll talk about volumes later and show you them later, where automatically I connect that image, that CD-ROM. It's like I map a drive to the local host. And we're going to do that. I'm not going to do it here, though. I'm going to do it later at runtime to make this a little more flexible. I don't want to map a drive to some poor user who doesn't know that Stuart's teasing me about my new webcam. I announced to the world that I have a new webcam. So um, let's take a look at what this gives us. I'm not going to run it right now. We're going to build one together fresh, and I don't want to change anything here. But let's look at what we have. So this is my GitHub, and this is the repository where that code was, right? There's the Docker Compose file there. Now, there's the README file saying how you at home can go into the DevNet sandbox, type in Nexus, and this is partly why I've done this. Bring up your VPN connection, and then you just say Docker run Merlin, and it will Nexus Docker, whatever the tag you want. It will just run those things through your VPN, either from Windows or from Ubuntu. Pretty crazy. So this again is a GitHub repo. Well, in Docker Hub, kind of like GitHub, try to make that connection. It's the same idea, but it's a hub for my Docker containers and my images, my tags. So here you can see that there's a lot. This is a whole new ecosystem. We're going to try to go through it slowly, but right, it's my name, and then this particular repo is Merlin. And then I have my images, my tags for the learned routing, learned ACL, learned ARP IP brief. I can push a new tag, meaning add an image, a tag to this repo through this command, or the public view would be how you at home can pull the container locally. And then you could run all the individual images or run the whole thing as a container. Now let's just go back to my view. Right here are my tags, and it gives me all of the pull commands here to pull those tags. The size, the compressed size, the last time they were pulled, their operating system, all kinds of information about the tags. Now, I want to show you builds, and we're going to use builds. I talked about, and here's my build history here. It's kind of like this view in GitHub. Your board of shame here, how much you've been contributing. Well, this is your build activity. I don't know if they make this public. I hope not. So you can see I had a couple false starts. Some build failed, and I was figuring it out. And I want to say no fault of my own. I'll show you what happens. So here are my builds in the cloud, and I can auto build them, and that's set to true. I can trigger a build. This is all cloud side. I don't have to run anything. And then it gives me my recent build history. I can go into a build, I believe. Let's look at IP interface brief. Well, here are the logs. This is what I could see locally here in Ubuntu if I do a Docker compose, and we'll do that, or a Docker build. Well, this is in the cloud. And it builds that whole thing. And then at the very bottom, right, you can see it's copying in the files and folders, and the build finished. Just incredible. In the cloud side. So then here I have my Docker file. This is what the instructions to the cloud said, right? How to build this. And then there's the README file. I have to fix these images, I guess. But pretty incredible, pretty incredible. Now, I have set up a webhook. I don't know, it's not working, or maybe I haven't done it right. There's not much to do. We're hopefully in my Discord webhook channel, I'll get a message when there's a build. I don't know. It's supposed to work that way. I haven't got that quite worked out. So now let's dive into how I can connect this repo here and a pull request. We're talking about GitOps here, where I'll show you, and we're going to make one together in a second and build something locally and build something cloud side. I have build rules, and I pick my branch, and this is why I have some failed builds. Oh, it doesn't show you. When by default they still have master here, and I didn't even think of it. I just clicked ahead. It's got to be main in GitHub now. And so I'll show you. I don't want to go too far ahead, but we pick our source, our main. I put the Docker tag in here, right? IP interface brief or learn routing. I point to that Docker build file. My build context is root, and I have auto build and build caching. And I can just save and build if it's there, or save it. I can even add a trigger, and I'm going to do this maybe later in the video. We'll try this, where I can send a post from Postman, or from wherever, a curl, whatever I can do, and it will trigger the builds based on that post it receives. I believe that's everything I wanted to cover for now. I'll come back to adding a new image and a new feature in the Docker Compose. Stick around.